Every year in the United States, an estimated 9 million people get sick, 56,000 are hospitalized, 1,300 die of foodborne diseases from at least 1 to 7 major pathogens, some of which are E. coli, Listeria monocytogenes, or Salmonella. After hearing these numbers, you might be concerned and saying to yourself, what are we doing to lower these numbers, and how can we prevent foodborne disease outbreaks?
Hi, I'm Paige Andrade, a rising junior at the University of Delaware, and I'm here to tell you about how someone like me keeps you safe from foodborne diseases.
This summer, through UD's Envision program, I began working in Dr. Kniel's lab, assisting on a 5-year-long project that was created 3 years ago through the FDA's Office of Applied Research and Safety Assessment in Beltsville, Maryland. The project is known as the Produce Safety Research Consortium and is now in its 4th year. In short, the Produce Safety Research Consortium is a surveillance and outreach project that works with small to mid-sized producers across the northeast region of the United States to strengthen their food safety protocols. The project involves collecting swabs from production lines, testing pre-harvest water and soil for early detection of various pathogens to prevent foodborne illness outbreaks and protect public health.
This summer, it was my role to collect these samples from participating farms and test for pathogenic bacteria such as E. coli, Salmonella, and Listeria monocytogenes. Now you know a bit about our project, let me take you along and show you what that process looks like.
Each week, we began with collecting samples from farms across Delaware. The number of samples we collected depended on factors like crop type, field size, water sources, whether animals were present, all of which can influence the types and levels of bacteria present, so it was important to ensure our sampling methods account for as many of these variables as possible. We collected 3 types of samples: swabs from production lines where produce is harvested and packaged, soils from the fields, and pre-harvest irrigation water. Back in the lab, I focused on testing the swabs and soil for E. coli, Listeria monocytogenes, and Salmonella, while my mentors tested the water samples for viruses and parasites. To test for E. coli and other coliforms, I used charm plates. Once plated, these samples were left to incubate overnight, and after 24 hours, the colonies were counted. Purple for coliforms and blue for E. coli. While coliforms are common, they're not harmful, whereas E. coli can be infectious and pathogenic, meaning it causes disease. These results were then recorded in a spreadsheet for further analysis and reporting back to the farms. We used a similar process for Listeria monocytogenes, playing on rapid agar plates and incubating overnight. After 24 hours, the plates were checked for any Listeria monocytogenes colonies. They would appear blue against the orange agar. If there were any suspected colonies, they were saved for further confirmation testing. It's important that these colonies are confirmed pathogenic species of bacteria rather than harmless. If confirmed, it is our job to report it to the farms and public health officials for further review. The results were again uploaded to the spreadsheet. Finally, we tested for Salmonella using XLT4 plates. These plates were incubated up to 48 hours but checked in on 24. Salmonella appears black on the red agar, while other bacteria may show up yellow. Any suspected colonies were saved for confirmation testing, and again, the results were uploaded to the spreadsheet for further analysis and reporting back to the farms. Processing each set of sample typically takes about a week or longer, especially when confirmation tests are required. While this may seem like a lengthy process, it ensures that each test is thorough, allowing enough time for bacteria to grow, which leads to more accurate counts and identifications. This level of precision is essential for reliable reporting back to the farms, helping them detect potential risks early and take preventive action before these bacteria can cause harm to consumers. In short, this is how someone like me protects someone like you.